Structure and properties of salt. Salts are a class of inorganic compounds that are formed by the combination of a cation and an anion through an ionic bond. Salts are essential in various fields, from the chemical industry to biological systems. In this article, we will explore the structure and properties of salts and their diverse range of applications in various fields. Structure of salts. Salts have a characteristic structure that is based on the arrangement of cations and anions in a crystal lattice. In general, salts have a regular, repeating pattern of cations and anions, which form a three-dimensional lattice. The structure of a salt is determined by the size and charge of the cation and anion, as well as their relative positions in the lattice. The most common type of salt structure is the rock salt structure, which is based on a cubic lattice where the cation and anion occupy alternate positions along the edges of the cube. Other common salt structures include the cesium chloride structure, the sodium chloride structure, and the zinc blende structure. Properties of salts. Salts have a wide range of properties that are determined by their ionic nature and crystal structure. One of the most important properties of salts is their solubility in water. In general, salts are soluble in water if the energy released by the hydration of the ions is greater than the energy required to break the ionic bonds in the crystal lattice. Solubility is also affected by the size and charge of the ions, as well as the temperature and pressure. The melting point of a salt is another important property that is determined by the strength of the ionic bonds in the crystal lattice. Salts with stronger ionic bonds have higher melting points, while salts with weaker ionic bonds have lower melting points. The hardness and brittleness of a salt are also determined by the strength of the ionic bonds in the crystal lattice. In addition to their physical properties, salts also have chemical properties that are important in various applications. For example, salts can be used as catalysts in chemical reactions, as well as in the production of ceramics and glass. Salts are also used in the production of fertilizers, where they provide essential nutrients such as nitrogen, phosphorus, and potassium. Biological applications. Salts play a crucial role in biological systems, where they are involved in various metabolic processes. For example, sodium and potassium ions are essential for the transmission of nerve impulses, while calcium ions are involved in muscle contraction and blood clotting. Salts are also used in the production of pharmaceuticals, such as the use of sodium chloride in the production of intravenous fluids. Food and beverage industry. Salts are widely used in the food and beverage industry, where they are used as preservatives, flavor enhancers, and texturizers. For example, sodium chloride is used as a preservative and flavor enhancer in processed foods, while calcium chloride is used as a texturizer in canned fruits and vegetables. Salts are also used in the production of cheese and other dairy products, where they play a crucial role in the coagulation of milk proteins. Water treatment. Salts are used in water treatment to remove impurities and contaminants. For example, ion exchange resins are used to remove ions such as calcium and magnesium from hard water, while reverse osmosis membranes are used to remove salts and other contaminants. From seawater to produce fresh water. Industrial applications. Salts are used in various industrial applications, such as in the production of metals and chemicals. For example, sodium chloride is used in the production of chlorine gas and sodium hydroxide through the chlor-alkali process, while ammonium nitrate is used in the production of fertilizers and